Я сказал, куда? Или сами? Его... Так, начинаем. Уважаемые коллеги, мы приносим извинения за определенную задержку. Там была дискуссия по поводу того, какую энергетику развивать. У нас 3 сегодня выдающихся спикера, лауреаты премии «Глобальная энергия». Кто-то занимается атомной энергетикой, кто-то зеленой, кто-то тем, что сегодня является актуальным, это использование цифровых технологий в энергетике. В любом случае, взгляд профессионалов такого высокого класса будет для вас и для нас всех полезным. Я желаю вам продуктивной такой дискуссии. Вынужден сам уехать, сожалею об этом, но по-другому не получается. Всем хорошей работы. Виктор Николаевич, вам слово.
Спасибо, Николай Дмитриевич. Уважаемые коллеги, продолжаем нашу работу. Сначала я хотел бы сказать слова благодарности всем, кто сегодня посетил нас, кто присутствует в этой аудитории, нашел время для этого. Ну и, конечно же, я хотел поблагодарить наших спикеров за то, что они тоже приехали к нам. Это для нас большая честь. Прежде чем начать нашу конференцию, я бы хотел представить наших спикеров. Это известные ученые, они являются, членами комитета по присуждению премии глобальной энергии. Итак, первым выступит у нас советник председателя группы лидеров и экспертов высокого уровня по проблемам воды и стихийным бедствиям при Генеральном секретаре ООН. Так, свет нам дадут или нет? Или не надо? Так, это профессор RaeKwon Chung. Прошу приветствовать. Спасибо. Далее выступит главный вице-президент по исследованиям и разработкам Халифского университета науки и технологиям Стивен Гриффитс. А также третьим будет выступать президент научного совета по глобальным инициативам, международный консультант в области энергетических систем Томас Близ, США. Уважаемые коллеги, я думаю, что доклады, которые будут сделаны здесь, они, в общем-то, весьма актуальны и имеют достаточно высокую научную и практическую значимость. Почему? Да потому что если мы говорим о современной энергетике, то современная энергетика должна отличаться чем? В первую очередь, конечно, это надежность, это высокая эффективность. И, конечно же, наша энергетика должна быть экологически чистой. И поэтому вот эти лекции будут посвящены как раз в том числе и этим проблемам. Но прежде чем начать выступление, я хотел бы предоставить слово вице-президенту Ассоциации «Глобальная энергия» Чуниной Анне.
Добрый день, уважаемые гости, студенты и представители MPEI. Меня зовут Анна Чунина, я вице-президент по номинационному процессу Ассоциации «Глобальная энергия». От лица ассоциации мне бы хотелось поблагодарить руководство и всю команду университета, а также лично ректора Иргалева Николая Дмитриевича за поддержку, оказанную нам при организации лекции. Вначале мне бы хотелось сказать два слова про нашу ассоциацию. Вся деятельность Ассоциации «Глобальная энергия» направлена на поддержание и стимулирование исследований в области энергетики. И мы убеждены, что важно способствовать развитию глобального энергетического диалога, в котором ведущая роль отведена ученым, в том числе молодым энергетикам. Нашу ассоциацию вот уже 15 лет поддерживают 3 крупных российских энергетических компании. Это «Газпром», «Сургутнефтегаз» и ФСК ЕС. Вкладывая в эту премию, они инвестируют в развитие достижений науки и технологий. Под своим началом Ассоциация «Глобальная энергия» вручает одноименную премию лучшим ученым мира за выдающиеся достижения в области энергетики. На данный момент лауреатами премии стали 35 ученых из 11 стран. И они не просто люди науки, они также разработчики передовых технологий. Наша ассоциация всегда стремилась вдохновить молодое поколение на веру в свои силы. У нас реализуется также ряд молодежных программ: «Энергия старта», «Энергия молодости» и «Энергия прорыва». Хотелось бы отметить, что сейчас у нас проходит набор заявок на конкурс «Энергия прорыва». В нем могут участвовать ученые, студенты, аспиранты высших научных заведений не старше 45 лет. Основной критерий для этого конкурса – наличие собственной разработки, которая внедрена на производстве. Заявки принимаются на сайте ассоциации. Финальная дата подачи 30 июня. С 1 июня стартовал конкурс «Энергия молодости» для молодых специалистов до 35 лет. Так что приглашаем всех ознакомиться и принять участие в нашем конкурсе. Сегодня в рамках программы «Энергии и знания» мы пригласили международных экспертов в сфере мировой энергетики, ведущих ученых мира, членов Международного комитета по присуждению премии Ассоциации «Глобальная энергия» для обсуждения актуальных проблем и вызовов в энергетической сфере. Мы рады представить вам спикеров, которых вам нам уже сказали. Это RaeKwon Chung, советник председателя группы лидеров и экспертов высокого уровня по проблемам воды и стихийным бедствиям при генеральном секретаре ООН. Он поделится своим видением об эконометрическом моделировании процесса глубокой декарбонизации. Стивен Гриффитс, главный вице-президент по исследованиям и разработкам Халлийского университета науки и технологий. Он расскажет о воздействии 4-й индустриальной революции на энергетический сектор. И Томас Близ. Он поделится экспертным мнением о перспективных ядерных технологиях, которые будут преобладать в энергетическом секторе в последующие десятилетия. Лекция будет строиться в формате диалога, поэтому приглашаю всех активно участвовать в дискуссии, задавать вопросы. Автор наиболее интересного вопроса, которого выберут спикеры, получит подарок. Это книга, выпущенная по случаю 15-летия премии. Она называется «Глобальная энергия. Книга о людях, изменивших мир». Вы также можете ознакомиться с электронной версией данной книги на официальном сайте globalenergyprize.org/ru. Ссылка на скачивание указана на ваших листовках. И мне хотелось бы поблагодарить всех в завершение участвующих в данной встрече. Надеюсь, вы с интересом проведете это время. А также хочу представить трейлер к фильму «Глобальная энергия 2030». Фильм рассказывает о том, как будет выглядеть наша повседневная жизнь в 2030 году с позицией энергетики того времени. Приятного просмотра. Спасибо.
Анна, большое спасибо. Итак, коллеги, мы переходим непосредственно к нашей работе. Первый доклад у нас сделает RaeKwon Chung. Тема доклада «Эконометрическое моделирование процесса глубокой декарбонизации». Прошу.
Good morning, and it's my great pleasure to have the opportunity to meet with you. And now I have my slides. This morning, I know that you are the students of Moscow Power Engineering, so you are mostly engineering and science-based students on energy sector. And I would like to present to you this morning my observation that the future of energy industry will be determined by the economics of climate change. And there are a lot of politics going on at the global level. You know the Paris Climate Agreement as well. So there are a lot of talk about how to transform our energy system. This is something already going on. And I'd like to present about some ideas about observations about this issue so that you can have a better idea about the future of energy industry in the future. And I hope it could be useful in managing or planning your future careers for your own life. So today what I want to talk about is not science or engineering knowledge, but this is related with the economics knowledge. I'm not sure whether economics can be called as a science. They call it science. Some people call it science, but some people have some other views. Anyway, so econometric modeling means that projections for 2030 or 2050, what will be our future energy situation after 20 or 30 years later, or even 50 years later. This is what economists are doing, and the tool they are using to make such a projection is based on econometric modeling. And I'd like to show you some of the efforts already going on, and I'd like to share some ideas with you. So I don't want to spend my time just explaining how serious the climate change is. It all depends on your personal judgment, and I don't want to impose it on you, but I just want to highlight the point that the extent that we are depending on, this is the kind of projections we got from the reports, many reports around the world, how much decarbonization we have to achieve by 2050. It is quite a very daunting challenge. I don't want to read all of this. Like 70% of global energy has to be clean by 2050. Share of renewable has to be around 65 in 2050. And 95% of the car should be from electricity sector. It has to be clean energy. 70% of new car has to be electric. All these kind of informations are available. So this is the extent of decarbonization people are talking about. Those people who are concerned about climate change are talking about this issue. So this is the level of decarbonization. So if we do this much decarbonization of our energy system, what will be the impact on our economy? I think that will be very serious subject for any politician, any businessman, and also for you as well as a young generation who has to find jobs in the future. So what will be the impact of such a transformation on economic growth and job creation? That will be, I think, one of your very important concerns. For that, these are the informations that how much fossil fuel has to be used, which means that we have to reduce our fossil fuel demand down to 45% of a current level by 2050. So these are the informations presented by the expert. But this is not the information I want to emphasize to you this morning, but the information I want to emphasize to you is the deep decarbonization, can it be compatible with our economic development? That is more important issue. And there has been some projections on what will happen if we decarbonize our energy system. So this is one projection from IPCC. The IPCC projected that global GDP, global economic growth, will be reduced by 3% by 2030. This is one example of the projection. This is by UNEP, Environment Program, projected that green economy will be even higher by 2050, even getting higher than brown growth. So this is another very contradicting projection from same international agency. One is from IPCC. IPCC is from Intergovernmental Panel on Climate Change. UNEP is a UN agency, but they have a very different contradicting projection. This is a projection from Cambridge Econometric Center. And this projection is showing that if we introduce a carbon tax almost around $150, something like that, which is very high, and to decouple and to meet the 2 degrees Celsius global warming target, then this econometric model is showing that GDP, if the revenue, tax revenue, is recycled, then GDP can even grow higher. GDP can grow even higher rather than lower. So this is also a very different message. So now I would like to just present some of these contradicting messages. For one projection made by a Danish expert, his name is Bon Lomborg, he predicted that EU GDP will be reduced by 1.6%. And the US will be 0.8% or all this kind of data. His projection is very negative, meaning that if we implement Paris Climate Agreement, then global GDP will be reduced by 2030. So spending $1 trillion every year, and we will end up reduced economic growth by 2030. This is the information distributed by Björn Lomborg in 2015 during the Paris Climate Agreement negotiations. This information made a huge negative impact on the minds of many politicians, business, and ordinary people, believing that climate action, decarbonization, will be very bad for our economy. So this is the kind of impression that this projection has given to all over the world. Maybe President Trump might be influenced by this number, maybe. This is why. But the point is, nobody questioned whether this number is really correct or not. Nobody questioned it. No media questioned it. They just reported it. They don't mention about assumptions. They don't worry about the limitations of the modeling, econometric modeling. But IRENA is the International Renewable Energy Agency, predicted that global GDP will grow higher, 0.8% higher. And economic gains will be like this, $19 trillion, something like that. And 26 million new jobs in the renewable energy sector. It is already, about 3 weeks ago, IRENA reported that there are more than 10 million jobs now in renewable energy sector. So the job is growing faster in the renewable energy sector. And OECD also predicted that GDP, is about global, the G20 countries, the GDP will grow even higher by 2.3% by 2030. But if we include co-benefit of health, environmental benefit, it can be even higher than 5%. So this is another projection from OECD. The reason why I'm showing all these contradicting projections is because that, in fact, the economics, the science of economics is not capable of making any precise projection for 2050. Actually, it's very difficult to make any projections. But the problem is, some of the scientists, economists, are distributing negative projections all over the world. And the people are impacted, the businessmen and politicians are impacted by these negative numbers. And they all believe this decarbonization will pose a serious problem for economy and jobs. That is a very negative perception that some of those negative projections had distributed around the world. This is why I am emphasizing it. So, based on these contradicting projections, the actual reality, we don't know. Actually, we don't know. So, then what should we believe? I want to just, this is an experience of Sweden. In Sweden, actually Sweden and Nordic country, very close from here, these countries are maintaining very high tax on energy, very high tax. So their electricity price and the gasoline price is quite high. And then if these countries have a very high energy price and also very low carbon footprint, and then what happened to these countries? Their historical record shows that Swedish economy has grown, constantly grown, while their CO2 emission has been slightly going down. So this is a historical record. So what I want to say here is that there are economists that are coming out with many econometric modelings. But these modelings are something that I don't think we can totally rely on those modelings. And we'd better believe in historical record rather than empirical evidence. And I don't have enough time to... yeah, this is my message, that we don't have to be fooled by the conventional economist, econometric modeling saying negative numbers for climate actions. In fact, many agencies are nowadays coming up with positive numbers. But for example, this is the number distributed by World Renewable Energy Agency about 2 weeks ago, and it is talking about that more than 10 million jobs were created, and also China is leading by 4 million, more than 4 million jobs in the renewable energy sector. So China is, out of 10 million jobs, China is having 4 million jobs. And this data shows that the jobs created depends on the investment. Each country is investing in the renewable energy sector. So China is now leading in terms of investment and also in terms of exporting solar panel, wind turbine, and the electric buses. They are actually exporting electric buses to UK and Germany and California, and now Korea is started to importing Chinese electric bus. So what I want to emphasize here is that the future of energy will depend on how strong are we going towards a decarbonization because of the climate concerns and the sustainability issue. Of course, the speed will depend on the politics. But what I want to emphasize here is that the more you invest in new energy sector, then you will get the benefit, the more benefit you will get from the renewable energy sector. Already China is already benefiting most from its investment in renewable energy sector. And what I want to emphasize as a closing remark is that whether this kind of a deep decarbonization will be promoted automatically by the market or by technology. I don't think so. That my observation is our first industrial revolution powered by coal, and the second industrial revolution powered by oil and electricity, and the third industrial revolution powered by IT, internet. All these past industrial revolutions has been automatically promoted by technology and the market. But the fourth industrial revolution towards deep decarbonization and also IT and all this related industrial revolution will not depend on only by technology or market. It will depend on government policy. It will depend on government policy, which means it will depend on politics and the political commitment. But this political commitment will depend on our ideas whether such a transformation will be beneficial economically for me. If we don't believe that such a deep decarbonization is really bad for my job, or for my own industry, or for my own industrial competitiveness, no country will do it. No country will do it, regardless of climate risk and the climate change damages. But so what I want to emphasize here is my personal idea is that investing in deep decarbonization will promote more jobs and more economic growth and the future industrial competitiveness for the future and the jobs. So this is the reason I believe we should think about energy transformation rather than just because of climate change. Even though I have been involved in promoting actions for climate change for my whole life, about more than 20 years, as a promoter of climate actions. But whenever I was arguing for actions for climate change to save the earth or save our life in the future, people don't buy that argument. That's why I came up with the idea of a green growth, green economic growth. Since 2005, I promoted that idea. The basic idea is if we invest in renewable and clean energy, it will drive our economic growth and job creation. That's it. That is the idea I wanted to promote, that I called as a green growth. So while I was in UN, I published a report titled Low Carbon Green Growth Roadmap, which compiles the policy measures which could promote the transformation of our energy system and at the same time can stimulate economic growth and job creation. And more gradually, agencies like IRENA and agencies like OECD are coming up, and also Cambridge Econometric Center, they are coming up with a new supporting econometric modeling that deep decarbonization is something we should be afraid of. Rather, it is something for our strategy, for our future industrial competitiveness, and for future job creation, and for future economic growth. So it all depends on what kind of ideas we will have on whether decarbonization will be bad for our economy or it will be good for our economy. So I think it will decide our future. But my conviction is that decarbonization will be a driver of our future economic growth and jobs. Yeah, thank you for your attention.
Большое спасибо, мистер Чунг. А теперь переходим к вопросам. Коллеги, у кого какие есть вопросы? И, конечно, помним о том, что глобальная энергия приготовила призы за лучший вопрос. Пожалуйста.
Вы считаете наиболее необходимыми, да, и может быть срочными, потому что на вашем слайде по Швеции видно, что, скажем так, налоговые поступления от повышенных налогов растут очень быстро, а уровень СО2 при этом хоть и падает, но намного более медленными темпами. Спасибо.
Thank you very much for a very good question, which I missed. I didn't explain about it because I didn't want to take too much time, so I skipped it. But that is actually the real crux of the issue, which means we need to introduce the pricing of carbon. At the moment, many of the countries and in our economy, we are not paying the real price of carbon. So we are using it without paying the price. So the idea is we need to reform our tax system so that we should pay not only for our income, because now our tax system based on income, but we should change it gradually, paying tax from carbon and income. So we increase tax from carbon and reduce tax from income while maintaining total tax revenue remain the same. We call it tax revenue neutrality. So we are not increasing tax burden, but we are simply changing the base of tax. This is one of the interesting ideas I was very much keen to promote as a real practical policy tools to promote the deep decarbonization, because it can be done while we can even stimulate economic growth and job creation and reduce CO2 emission without creating additional tax burden. We call it ecological tax reform. This is an idea. There's a lot of literature available. So if you are interested, you can look into Google ecological tax reform. And what I did in my slide was that whether such kind of a tax reform can be even applied in developing country. Because many developing countries argue such a tax reform is only feasible in developed country, not in developing country. So I did the econometric modeling again, and I found out, not me, but my expert when I was in UN, found out that even country like China, or a country like Korea, or Thailand, or India can have positive impact of economic growth, job creation, and reducing CO2 emission. So this is one of the idea. You can find it in the Low Carbon Green Growth Roadmap report. You can download it from Google. Thank you very much for your question. Any more questions?
Добрый день, меня зовут Евгений из компании Русгидро. В Очень интересный доклад, спасибо вам большое. Вы абсолютно правильные цифры называли в перспективе до 2050 года и называли некоторые инструменты по поводу того, чтобы достижение к этим цифрам. Но все эти инструменты, и вот в частности Швеция, да, это яркий пример, они будут ложиться все равно на плечи потребителей. То есть, как бы вы ни играли бы налогами, как бы вы ни подходили правильно к руководству энергокомпании, все равно это все в итоге ляжет на тариф конкретному физическому или юридическому лицу. И в связи с этим у меня вопрос следующий. Вот вы выступаете как бы и перед молодежью, да, перед нами, и проводите какие-то политические моменты на высоком уровне. Но ведется ли работа непосредственно, так скажем, социальная, чтобы до людей непосредственно на местах доносить эту информацию о том, что в перспективе все-таки когда-то плата за углеводороды настанет, и им придется платить, ну вот, например, в России 4 рубля за киловатт платят, да, люди там, а им придется платить 6 рублей за киловатт, чтобы потом к 2050 году все-таки обеспечить вот эти показатели, о которых вы говорите. То есть, может быть, не вы этим занимаетесь, но вообще в вашей организации, например, проводится ли такая работа, чтобы вот это социальное направление, чтобы люди понимали и осознавали, что в будущем все-таки расплата, она настанет. Спасибо.
Okay, thank you very much for once again also a very important question which I didn't actually cover. And that is exactly the reason why many governments are find it very difficult to push this kind of transformation or tax system. So some countries introduce special measures to protect the handicapped, low-income people, to protect from rising energy cost. So it is a matter of what already many literature, already many analysis are done that this kind of carbon pricing can be introduced while minimizing negative impact on the poor people. So there are many social policies already available and developed and introduced in many countries. For example, in Korea, we have a very cheap price until a certain level of electricity consumption. But when it goes above a certain level, it becomes very expensive. So there are many ways of minimizing social impact. So of course, this is a very important issue, but it will depend on each country what kind of special measures the government should take. But what is clear is that even OECD clearly mentions that social protection can be compatible with carbon pricing. And even many of the big companies, global big companies, they mention that companies do not objecting to carbon pricing. What they don't like is uncertainty and risk rather than carbon tax. If the carbon tax can be introduced in a very gradual and predictable way for a long-term schedule, based on long-term schedule, then the companies say, we don't have any problem of accepting carbon tax. That was the business's point of view. Their problem, the number one risk is uncertainty. It's not carbon tax itself. So if the government can provide a long-term predictable schedule of how to increase carbon tax in the long run, the business can adjust, and even people can adjust their lifestyle and their efficiency. So this is a matter of how, but many OECD and many literature already available saying that that is possible, and many countries are already successful in doing that. Yeah. Any other question?
Ожидать.
Firstly, I want to say thank you for your work you presented. I'm a master student from electrical engineering department from this university, and I want to know your opinion. What do you think? Are there any prospects for decarbonization in Russia? What do you think about this? And because everybody knows that in Russia this field is not profitable. And what do you think? How we can do it more profitable for people, for companies? And thank you.
Once again, it's a very important question. Of course, for me, Russia is very fortunate, very blessed to have a very rich endowment of oil and gas. So we are very lucky. Korea, we don't have one drop, not even one drop of oil in Korea. But Korean economy still okay, right? So I don't think the economic performance will only depending on oil and gas. But the question for Russia is, Russia also has huge potential for clean energy, hydro, and also geothermal, and many other energy sources, even biomass. So you have a huge potential for renewable energy as well. So it is, just as I said earlier, it's a political decision and the national consensus whether you will remain with your own industrial competitiveness based on fossil fuel, which is, for me, is the competitiveness of the past already. But whether Russia is willing to create new industrial competitiveness for the future, then you need to push for, not because of the climate change, but because of your national competitiveness issue. This is the reason why China, even Korea, many countries are trying to invest in this kind of a new energy sector, not because of climate change, but because of future industrial competitiveness. So it is, basically a political decision. So I think that also political decision depends on whether the leaders or people have a positive idea for the transformation or negative idea on the transformation. So it will decide the future of Russia, I think. Yeah. Thank you.
Здравствуйте, Никифоров Максим, аспирант энергетического института. У меня такой вопрос. В качестве основных достоинств декарбонизации экономики вы называете создание миллионов новых рабочих мест. Однако возникает встречный вопрос. А не вызовет ли эта декарбонизация соответствующее снижение рабочих мест в традиционной энергетике, и это указанное преимущество будет нивелировано? То есть в одной отрасли экономики число рабочих мест увеличится, в другой уменьшится, и баланс таким образом останется плюс-минус одинаков. Как вы это прокомментируете? Спасибо.
Okay, thank you very much for once again the very important question. Yes, certainly there will be offsetting impact because of this, as you say, but many of the research came up with a result saying that renewable energy sector is employing more than conventional energy sector. So that can be naturally a concern for a country like Russia, but my personal observation is I don't think Russia will lose jobs because of this decarbonization in the world. Rather, I think Russia can maintain at the current level of employment in the conventional energy sector. But the issue is, how can you create additional new jobs in a new sector? I don't think this decarbonization will replace the current Russian conventional energy sector, but it's a matter of how to create additional new sector in the renewable energy sector. I think that can be the strategy for Russia. Yeah.
Спасибо, коллеги, за вопросы. Но, как мы и договаривались, самый лучший вопрос за лучший вопрос глобальной энергии сегодня предоставит призы. Мистер Чунг, с вашей точки зрения, какой был лучший вопрос?
Okay, I decided. Okay. The question on the tax.
Вопрос о налогах. Автор вопроса. Глобальная энергия. Вручается вам книга за лучший вопрос. Спасибо. Итак, коллеги, переходим к следующему докладу. Следующий доклад у нас сделает Стивен Гриффитс. Его доклад, тема его доклада следующая. Воздействие четвертой индустриальной революции на энергетический сектор. Пожалуйста, Стивен Гриффитс.
Good morning, everybody. It's a pleasure to be here today. You've heard RaeKwon talk a little bit about the fourth industrial revolution, and so that's what I'll have is the context of my talk today. The fourth industrial revolution is extremely important, and so I'll talk a bit about what the industrial revolution is, talk to you about the technology of the fourth industrial revolution because they will be transforming our lives in many ways over the coming years, and then I'll talk about how in order to use the tools of the fourth industrial revolution, we need to understand the context. And so as you might be aware, the Khalifa University is in the United Arab Emirates, and the research university I come from is the only research university really working with the government to develop an energy strategy. So I'll talk about how we're using the tools of the fourth industrial revolution to build the strategy, and then I will come back to a few comments on how I've seen the Russian energy system and how we can build tools that are relevant for Russia. So with that, let me start off just by reflecting on what is industrial revolution. And so there have been three so far, and industrial revolution is simply the evolution of new technologies which are transformational in the sense that they substantially change the way industrial practice is done. And so if you think about the 18th century, the first industrial revolution, as you heard earlier, was partly dependent on coal, but I more so like to say it was about steam and the mechanization of labor. And there were other inventions in the same period which helped industry to grow around mechanization. And it included even evolving how you would develop industry with improved forms of hydropower energy. Then about 100 years later, there was a second industrial revolution, and that one was based on inventions which allow us to produce electricity, which dramatically changed the way in which industry was able to do its work. As you can imagine, being able to do work 24 hours, having lights continuously, not the danger of gas lamps and such, was quite revolutionary. And so we had this revolution that took place. And it held for a number of years, and it was complemented by oil, of course. We talked about that, and that was transformational for transportation. But it wasn't for about another 100 years, around 1970, that we hit the third industrial revolution. Just before that, there was the invention of the integrated circuit, which allowed microelectronics to take hold and really become quite important in everyday life and in industry. And so this third industrial revolution was really about automation and seeing how we can do new things with automation of our work practices. And so that's been really the industrial revolution that's happened for the past few decades. It's been about digital and automation. Now we're in this fourth industrial revolution, as you see here. What's said on the screen there is cyber-physical systems, which is a fancy word for Internet of Things, but it's much more than that, and that's going to be really the basis of my talk today. Before I leave the screen, though, I'll talk just briefly about one idea to get you going with the concept of how the fourth industrial revolution, or 4IR, is relevant to the power sector. You see a quote here, if you're familiar with some of the major players in artificial intelligence. Andrew Ng is quite important in Google and Baidu, a Stanford professor. he said recently that AI, one of the tools of the fourth industrial revolution, is the new electricity. And so as you can see, we start to have this cycle where we have now a new tool which reflects back on the second industrial revolution and may be the new platform to launch us into great things for industry and power, as I'll be talking about today. Of course, although AI may be the new electricity, electricity itself is going to be dramatically impacted by artificial intelligence and other tools of the 4IR. And so this is a recent IAE study, a graphic from it, talking about digitalization in energy. And as you can see here, some of the tools we have, data and analytics, and I'll go into great detail about some of the technologies behind that, is allowing us to do radically new things in reducing operation and maintenance costs, improving efficiencies in a number of ways. Here you see reduced investment costs is one area, reducing, of course, the requirement for asset investments, and then likewise reducing carbon emissions, as RaeKwon had said previously, is something that's quite important, although for me, it's more of a byproduct of evolving toward greater levels of technology, which are revolutionary. And then there is the reduction of unplanned outages in power, and then finally extended asset lifetimes, which you'll see later. This will be very important for Russia's power sector, because one of the compliments I think the 4IR has for Russia is allowing us to see how an aging power system can evolve in a smart way. And then I'm going to get into the connectivity piece later. This is, as I mentioned previously, we talk about cyber-physical systems. Connecting together assets and having them work together in a unified way is revolutionary. It's IoT, it's industrial IoT in many different ways, and we'll talk about that. Before I go further in the electricity relationship with 4IR, it's always important and kind of interesting to think about what are the tools and technologies of the fourth industrial revolution. It's not just cyber-physical systems. In fact, when you think about the 4IR, it's a convergence of many different sciences and technologies. So the life sciences, the biological sciences, material sciences, information sciences, they come together in a new way, and they allow us new things. And likewise, you see the physical and the digital worlds start to converge and allowing us to do new things. So our interactions today with our cell phones is the beginning. As you can see here, and I'll talk shortly, there's some other powerful technologies which allow this convergence to happen. I'm not going to get so much into the bio, but I like to have it here because I talk about the 3 O's of the fourth IR. There's the bio, info, and nano. And so in the middle is where I'm going to spend most of the time, but I will say biological technologies is revolutionary, and so synthetic biology using tools which you may have heard of, CRISPR, talent, and such, to shape life as we want it in a way that we do in a directed manner is quite transformational. On the material side, again, it sort of relates here as I put it. There are the advanced materials we won't get into, but certainly three-dimensional printing is digital, and that's one of the technologies that's going to be transformational. And then fourth-dimensional printing, and so having shapes change form based on context after developed. But I think the middle is very important. That's where I want to spend the time. So the Internet of Things is this ability to connect together different systems through sensors, and you'll see some more of that, and then have intelligence done to get information and analytics from that. Then there are the big data analytics. Let's say this is still sort of today's technology realm. And then getting into where the future is really headed is artificial intelligence, which I'll spend quite a bit more time on. And then finally, the robotics and drones, virtual and augmented reality, and then the blockchain, which is very, very relevant to distributed energy, but won't be one of the key topics of today. I'll focus on some of the other areas. So I wanted to just spend a minute on these technologies. The last slide was a little bit high level, a little bit abstract. I spend lots of time doing technology forecasting, working with a company called Lux Research, and every year they put together a set of transformational technologies for the future. And what I wanted to point out from this slide was not to go through every single topic, but when you start to categorize into the 3 O's, you'd see that almost everything here, actually everything here, can be categorized as bio, info, or nano. Very importantly, the digital or the info area encompasses about 11 of 18 technologies here, and so extraordinarily important. We could go through in great detail each of them, but I wanted just to mention that the first one is one area that I think we really need to think about, the area of artificial intelligence. As you'll see, there are other areas. I mean, artificial intelligence has many different topics included, but machine learning and deep learning is an area that everyone really associates with AI, and so I'll go through that. But I would say, you don't want to forget that all these other areas are quite important to the power sector, especially when we think about connectivity, 5G networks, very high data rate, low latency, high bandwidth networks, which will be transformational to transportation systems, industry, and the power as well. And then things like wireless charging. If you thought electric vehicles are highly inconvenient, then maybe one of the ways in which we'll be able to do that is having more intelligent power delivered through wireless systems. Again, It's intelligent systems, which is allowing us to go further toward digitization, allowing things like autonomous vehicles to become more relevant. So I just want to make that point on this slide. On the AI piece, this is where we're spending a little bit of time because it really is quite important. AI is not something that just the industry has been focused on. So I think two people that you might want to consider what they've thought about AI. One is Sundar Pichai. He's the CEO of Google, and so at various talks, I've been to several, he said many times that in the past decade, Google was a company that was really mobile first. The mobile phone was what they were oriented toward, collecting people's data. Now they're an AI first company, and so they're going to build their future toward artificial intelligence. In the political realm, and here in Russia, and I think it's quite appropriate, everything that's been said, Vladimir Putin has said that artificial intelligence is critical not only for Russia, for all humankind, which is absolutely correct. And in fact, those that are able to master AI and utilize it to their advantage will be rulers of the world. And I think if you're familiar with anything that China is doing now and their strategies for artificial intelligence, you see many countries which want to be the most sophisticated in technology are becoming leaders in artificial intelligence. So every country, every industry should be thinking about this. So with this background, I think you want to look at the bottom picture. What is AI? People talk about it and they refer to it in a very abstract way. The way I see AI is you have today's ability to collect data and leverage the data. And so we have the big data analytics, we have the Internet of Things. It's created one big part of what is artificial intelligence. If I see three things, there's hardware evolution, there's access to large amounts of data, and there's algorithms. The data collection piece we've got down pretty well. The second is more interesting, though. It's how you take these data and start to do new things with them. And I think that's where AI becomes a bit more interesting and where one has to consider it in greater depth. So if you've been in data science, if you're a computer scientist, you probably know some of the tools. I wanted to point out, if you flow from the left to the right, AI starts with a toolbox. So when people talk about the deep learning and they talk about reinforcement learning, it's just a couple tools which now allow us to do things to make computer-based systems more human-like in all the ways stated up on the top line. But I say it's giving us the ability to have computer-based systems have sort of a situational awareness, be aware of the world around us, and also have foresight, be able to predict the future in a meaningful way. So you take these tools, and we'll spend a little bit more time probably on the deep learning and reinforcement learning because that's the popular technologies, but not so much spend time on those per se, but what they can do. And if you take these tools, you package them up, use them in combined, unique, discrete ways, then you do things that are interesting. I don't think deep learning itself is interesting at all. I think it's what you do with it. And so if we start to look at things like computer vision, the way computers can hear, they can translate what's spoken into an understanding of the language. If you look at the way in which we can take natural language processing and convert spoken language and information into text in any language is quite interesting. And then anomaly detection for cybersecurity is something I'll mention again. And things like collaborative filtering would be used in social media and for some of the businesses which are selling online products. And then if you're ever working with robotic systems, motion and path planning is a way in which you use AI, for instance, for robotic systems. And a vehicle, for instance, autonomous system would be using AI for this. And then finally, recognition of patterns in a deeper and more meaningful way. In the end, what you get when you start to then combine these, if you say take motion path planning, computer vision, and natural language processing, you may have a robot which can do something all the way from assisting you, the way a cell phone that using AI and its data can give you information, to a tool that will allow you to be better at what you do, such as with augmented reality. Anybody who's ever seen the Google glasses is very familiar. If you like Iron Man, sort of that's the way in which the augmented reality, bringing real-time data, bringing forecasting predictability, and then augmenting your ability to do new things would be the state of the art. Sometime in the future, there may be fully autonomous systems which don't need any input from humans and can work fully on their own, and that's the ultimate of, say, the autonomous vehicle, level 5 autonomy, which, although some companies will say they're there today, they're actually not. So this gives you a sense of where AI is, and I think now what we want to do is think about how we use AI and other 4IR tools in order to transform economies. And so now I'll come back to my thought on how this is done and give you some examples and case study. So to take the 4IR, take any of the tools, I mentioned artificial intelligence because you'll hear about that in a couple slides here, but you really have to understand what the strategy is of a country, and you have to understand then what your short-term operational plans are in order to implement this strategy. And when you have that, you can then use any of these tools as appropriate for the context in order to transform business or economy. And so, as I mentioned, the Khalifa University, where I've come from, and I'm overseeing the research, it is the research university that looks over the nuclear and the renewables and all of the hydrocarbon sector for R&D. And so what we've done is we have worked with the Ministry of Energy and Industry to see what their strategy is and figure out how 4IR fits into it. And so here there's energy efficiency, doing things 40% more efficient than business as usual by 2050. And then there is a energy strategy which, because we have great resources in solar energy, for instance, looks at having 50% of our energy from clean sources, having 6% from nuclear energy. We have that going as an industry now. And then finally the fossil-based energy sources, including clean fossil, will be the other half of the energy. And so we don't forego natural gas and such. We even have clean coal as part of that other 50%. But it's using it in a way that we think is most appropriate. But to make all this work, you need new 4IR tools, and that's what we were asked to develop. So what we've done is we have a strategy which has verticals and horizontals. Vertically, we have in the color all of the energy and sustainability sectors. I won't get into the other sectors we work on. And then on the horizontal is where you start to see the artificial intelligence, data science, robotics, and ICT in the sense of cybersecurity, sensing networks. I mentioned 5G networks for connectivity, all those other things we do, and then the advanced materials and manufacturing. Most important there, we do lots of robotics for industry, and we also get into three-dimensional printing. That's how we've seen it. And then what we've done is we decompose this into focus areas. I'm not going to go through all of them. The top left box for you is where we'll talk more about the solar energy, the power transmission and distribution, which we've worked quite a bit on, and then nuclear energy, and then figure into the bottom green box on the specific focuses we have, where we'll talk more about the machine learning and the deep learning, those types of things, cybersecurity, and then leveraging the data we get from advanced sensing networks. And so this is how we put it together. And the key to the whole thing is understanding the strategy of the country and then trying to make sure this is a reinforcement. We don't verticalize or segregate sectors vertically, and we don't just focus on fundamentals. It's trying to bring it together so that teams work, and you'll see how that works. On the first area, I mentioned that it's very important for us in the country to focus on solar energy. And so one area where we've applied artificial intelligence tremendously is in trying to understand the solar resources we have. And so what we've done is we were asked a few years ago to develop a research center which is using satellite remote sensing in order to understand all of the solar resources in the country and build that out with different organizations. The center's been very successful, and so I just mentioned a few of the partnerships. We now with the International Renewable Energy Agency have helped them build all their entire global atlas with some of the work done at the center. We store it at the university. The data from the atlas is with us. We've worked with the Ministry of Energy and Industry, again, to site all the photovoltaic plants in the country, as you'll see how that's done shortly. And then working with Ministry of Climate Change and Environment, Saudi Arabia, Total, which is an energy company we're familiar with, helping them all to adjust the way in which they understand solar resources using the tools we have. Now, I'm not going to spend too much time on the picture, but you will get a sense that we do, this is the Masdar Institute, so we have the Masdar Research Institute underneath the research at the university. That is a schematic picture of what the campus looks like. We're not so much in the desert only in Abu Dhabi, but it is in an area we get a good signal from a geostationary satellite. We have satellite receiving station, and we get all these data, and then we want to do something important with that. And what we do with the data from the satellite in order to help with the solar resource assessment is we get 6 thermal channels from the satellite, and we have another number of other ambient parameters that allow us to feed a neural network, a machine learning network, with lots and lots of parameters information. And so we extract these parameters and train a system against what we know are the ground measurements for the diffuse horizontal, the direct normal, and the global horizontal radiation. Train a network so it's properly calibrated to be able to receive new satellite data, new environmental variables, and then be able to give us at any time what the solar resources for all the components throughout the country. We took these data once we did the solar map for the country, and we've done that now in Saudi Arabia and elsewhere, and then built tools where we could then look across the country and plan out what the economics are of siting a photovoltaic plant or a concentrated solar power plant. So we've used this to translate the machine learning, which I said in itself is not the important thing. It's how you use the technology to do something good for the country. Of course, when you have solar energy, you then have to have this distributed across the power grid, and then you have to have it also working from the distribution back into the transmission lines. So in the country, as we adopt, we have nuclear energy now, we have fossil-based power plants, we have solar energy. The question came up was we're going to have a lot of challenges in the grid. So the diagonal upward is all things we now worry about. So there's the system inertia, the power quality, the grid stability, and then some of the cybersecurity. Once we have more embedded systems in the grid, there are openings for attacks on the grid itself. And so we have to now think about technology coordination. So beyond the cyber things, how we'd start to look at bringing more of the energy storage to the grid. The country now, we're now doing a new project on electric vehicles, how that'll impact the grid, and then just in its natural operations, transmission distribution networks, they can sometimes have stability problems, which we've had previously, and so how we bring all this in with active transmission distribution, DC-AC networks, microgrids, and make it all work together. So what we did with what we've done with the machine learning part is we built two tools with our Department of Energy, and so the intention here was to mitigate uncertainty of renewables, to help them with that, then to provide intelligent control of the grid in general so that we can detect disturbances, and then finally the cybersecurity part. We have one tool, which is the Renewable Energy Management System, which allows us to do machine learning and deep learning to collect the environmental data, which I've talked about, the weather data, to understand the grid topology, the storage we have available, and then also what the loads on the grid are, and then feed that into an algorithm which can provide in real time a feedback, human loop, ability to dispatch appropriately energy in various different ways. The second tool is one to look at the grid quality. So on the far right, you're familiar with how you measure the grid. So there's phasor measurement units, there's SCADA measurements, there's power quality meters. We take those tools, we feed them into two different systems. One is a physics-based system, which allows you to understand the model of the grid and predict when the measurements we're getting may start to trigger or help us understand there's about to be a problem with the grid's operation. The second one is machine learning, so taking the same measurements and then calibrating against historical grid disturbances and building a network which is robust to detecting in a more holistic way the potential for failure. So this is sort of a key paradigm of artificial intelligence machine learning. When you do machine learning, it's called holistic, because you don't know what the model is, and you're able to predict an outcome, because like us, we don't always know how we do things, but we're able to do them because we have experience and our brains are able to allow us to do things without doing detailed computation. The other is the physics-based model. You'd think you have a model, but models are always wrong, but they allow us to have better insights when we start to build them and try to interpret them. So that's the physics-based approach. They both come together and allow the grid operator to start to understand when there might be a problem, and again, a human-in-the-loop ability to control the power grid. So that's one of the tools to help us incorporate then energy in various different ways, electricity in various different ways. The next area is about the true collaboration. So with nuclear energy, it's very important for us. And so we have a nuclear technology center, which is very focused on helping us to develop the sector in a safe way, not so much new nuclear reactors, but reactors we have operating safely. And so we look at the three levels of containment for nuclear. One is on the fuel rods themselves. The cladding is one level of containment. Then looking at the water, the pressurized water barrier is the second level of containment. And finally is the buildings. The center focuses deeply on this. So all that we do, lots of thermal hydraulic modeling about the reactors, lots of looking at how there may be cracking in the reactors, there may be corrosion on some of the materials from the salty and hot environment we have. That's not as important, I think, as some of the things I'll talk about in collaborating with our next center. Just to mention also in the Center for Nuclear, we do lots of radioactive or radionuclide modeling for what would happen if there were an accident. So marine modeling, atmospheric modeling, which is in itself a big data analytical problem. But I think what's important is we have this other center on cyber-physical systems, which is the Internet of Things, so to speak, which allows us to think more about cybersecurity, think about collecting data, really focuses deeply on artificial intelligence, and then has a computational architecture around that. So these two work together to try and find new interesting ways in which we can bring artificial intelligence and 4IR tools together. And so what we've done, this is a project with KAIST. One of the things of cybersecurity, which is not intuitive but does require new tools, is trying to figure out insider attacks. Cybersecurity, if you have an open network, of course someone can intrude and use anomaly detection, for instance, to figure out if there's been a cyber attack. It's more problematic, though, if someone inside the facility has been compromised and may do something because they're under a duress. I'll explain a little bit of that in a second. If you want to know if someone inside the facility, who's an employee, for instance, would be motivated to do something detrimental to the plant, one of the trends, and I didn't talk about it, Neuromorphic Analysis in the prior slide from Lux Research, is to measure the electroencephalogram, so brainwave activity. The brain electrical activity comes in multiple frequencies and multiple different outputs, and so if you can collect these data and you can match these data against certain behaviors, you can start to build a neural network which allow you to predict the onset of someone starting to have a deviant behavior. And so with KAIST, which they also have in Korea, very robust nuclear activity, we have a joint project where we collect information, the EEG data, from people that are experiments. Of course, this would be nuclear reactor, power plant reactors. We collect the data when they're subject to different stimulus, which allow us to see how their brain activity changes when, for instance, we give them a simulation where one of their family may have been kidnapped, and they're asked a question, what would you do if you were asked to compromise the facility to get your family member back? If they answer they would compromise the facility, we measure the brain electrical activity. If they answer they wouldn't, we measure the brain electrical activity. You therefore can start to build a pattern of how brain electrical signals change based on how someone's mental state is. It's about cognitive function. It actually works fairly well. Some of the things we do is you subtract out background data from brain activity when you start to have people moving and such, but you can get a fairly good, reliable signal about one's intention from their mental activity. So that's using the 4IR for nuclear. Now I was asked to talk a little bit about, sort of in the closing part, about how 4IR could help Russia. And so I'm not an expert on the Russian power system or energy system. Probably you guys know quite a bit about that, more so than myself. But in order to give you some insights, as I said, you have to understand the context. So gathering, of course, Russia, a very robust hydrocarbon-based economy. There's nuclear energy and such. It makes perfect sense to stay oriented in this direction to some extent because Russia does have the largest natural gas reserves in the world, very, very large amounts of uranium, a well-built nuclear industry. And so this is what we would expect as we consider how to deploy tools. You wouldn't expect this to radically change. That's one contextual issue to consider. When the power generation is considered in its own right, it is an aging fleet. So even though it may be thermally oriented to the future with nuclear new build, the fleet's getting old. And many of these power plants, no matter what form of energy they burn, are very old. They're multiple decades old. And so something has to happen to upgrade the fleet or change it out. I think upgrade is going to be probably just as likely as anything else going future. And so that's going to be one of the areas in which 4IR could be considered. And then renewables, as mentioned, last year IRENA released a report about renewable energy opportunity for Russia. Total final energy opportunity, if it were all realized, would be about 11% of final energy in Russia from renewables. I think probably the power sector, if it were a perfect world, could leverage biomass, and particularly to get up to about 30% renewables, and then district heating could be complemented as well. So there are opportunities for renewables, and as you'll see here, I think about that more in the sense of how you can transform communities which don't have energy using fourth industrial revolution type of capabilities. So the thoughts on power generation, there's a number of things that one can do. So the biggest, lowest hanging fruit in 4IR tools, I'd say, for power generation is deploying sensors in power plants. It's called the industrial Internet of Things. You don't want reactive maintenance of plants. You want to be proactive or predictive. You can do that by training systems on failure events. Also, there is what we call the digital twin. And so once it's a little bit of a takeoff of what I just mentioned, you sensorize plants and you create in silico or a computer-based model of the entire power plant. And then you can watch the model and you can watch the plant operate in real time and start to predict events before they happen and figure out what would happen if I did something in the plant. Digital twin is quite important. Then there's the augmented virtual reality. You would like to have workers be more productive or safer, as I mentioned, the ability to have a situational awareness. You can do this by having things like the Google Glasses or what have you, giving real-time information. And then finally, there's cybersecurity and the internal threats, which is another opportunity to prevent problems with the power plant. For the transmission networks, you've already seen how we do this in the UE, and I'd say you'd like to be able to have analytics to take the real-time grid measurements. We talk about phaser measurement units and power quality and SCADA systems, and be able to use those in the types of models we talked about for the UE. You can look at trying to moderate load, and so intelligently be able to moderate how you deal with demand rather than always worry about supply. You can turn up and turn down demand so that you don't have to build as much new capacity to meet peak generation. And then there's, again, cybersecurity for network embedded systems. And you open up the grid for communication, you open up for cyber attacks. And so that's another area where 4IR technologies such as anomaly detection come into play. And then finally, there are 11 million people in Russia, this is what IRENA has said, that are off the grid. And so you can create microgrids, which are intelligent. They coordinate clean energy with storage, maybe diesel generation as needed, and they can operate to bring new people that don't have energy opportunity. Then there's Internet of Things, analytics. So if there are people in remote areas, you don't want to send operators to see if there's a problem. You'd like to have predictively maintaining the operation. If you can predict the failure, you could potentially, in a very challenging area, send an autonomous system, a drone to help with inspection, or if they become more sophisticated, be able to fix the system autonomously and remotely. And so that is it. I was left you with this final thoughts on how the 4IR could relate to Russia. Again, the message is there's a number of tools now. They're evolving quickly. They're very powerful. But to use them correctly, it's to use them in context. Thank you.
Да, добрый день, меня зовут Иванов Андрей, группа компании «Русгидро». Смотрите, у меня вопрос может показаться несколько консервативным по первой части вашей лекции. Смотрите, мы все говорим о том, что после того, как закончится четвертая промышленная вот эта революция, ну или будет иметь развитие, большую часть, огромную, вернее, часть всей деятельности будет выполнять искусственный интеллект. У меня вопрос следующий. Как именно вы, мне вот очень интересно ваше мнение, видите место именно человека в этом будущем? То есть сразу же приходит в голову мультик Валли, знаете, это где неповоротливые люди, не имеющие никаких желаний, ничего, и вот искусственный интеллект выполняет всю работу, да? Вот конкретно, где наше место после окончания четвертой промышленной революции? Спасибо большое.
Появились вопросы по четвертой индустриальной революции?
That's a very good question. Thank you for taking that. So, as I mentioned earlier in the talk, there's different types of artificial intelligence. There's the artificial assisted intelligence, the artificial augmented intelligence, and the full autonomy. I personally believe that we're going to go in the fourth industrial revolution to the extent that AI assistance and AI augmentation are going to go very far. We'll have people be much more productive. We most likely will eliminate using autonomous systems. What I like to think is the best use of them is getting rid of the dull, dirty, and dangerous jobs that you don't really want people to focus on. But I don't know how far we'll go with fully autonomous systems to replace people for value-added jobs. So if we want to, for instance, look in a nuclear reactor accident, you wouldn't want a human to have to do that. You want to have a system which can do that autonomously and help with the cleanup. When you're working in oil and gas inspection, when you're working underwater, when you're working in remote platforms, these are areas where you could remove people from the job and put them in other more useful jobs working with the system so that you don't displace the number of jobs that you would have otherwise if you just said everybody can go and the robots can operate by themselves. So I think AI, the scary part of it is if it becomes so intelligent, you can replace lots of people doing the higher value jobs. I think there'll be more of a middle layer where you'll have a number of different opportunities to use AI and robotics that complement AI to help people rather than fully displacing the work that they do.
Уважаемые коллеги, нас смотрят сегодня наши филиалы, вот они на экране. У них есть тоже вопросы. Пожалуйста, Смоленский филиал, ваш вопрос.
You can hear me, yes? I have a question about AI. Will be produced by such companies as Google for every facility, or there will be just the one AI and it will be developed over time? Thank you.
Вас плохо слышно. Еще раз, если можно, повторите.
I have a question about AI. So it will be produced by such companies as Google, and it will be only one AI that will be developing over time, or it will be developed for every facility. Thank you.
That's a good question. I think the question was, would a company like Google be the only company that eventually evolves to be the one that develop AI that we have to use? Yeah, I think the challenge of it is when you look at artificial intelligence as it evolves today, the way in which it works is, and the reason AI has become so powerful is not that it's a new concept. I mean, that started it's back in the 50s, people were working on artificial intelligence. It's now that we have, in one regard, much more powerful hardware to be able to run the algorithms, which they had already started being developed many, many years ago, but it's the data. So the thing with the artificial intelligence as it's currently constructed with deep neural networks and machine learning is the more you have the data, the better your systems are. And so countries such as China, as you look at the way in which they're developing their AI, they have massive numbers of people, they're collecting massive amounts of data, and so their AI systems are coming better and better and better. I think as long as deep learning and machine learning is the predominant way in which we view artificial intelligence, those with the data and those who are willing to share the data with will be the ones that are doing the best as far as moving forward in artificial intelligence. That said, I think most of the people that are talking about AI evolution in the future, we probably won't get to the fully autonomous realization of society or fully autonomous systems around artificial intelligence using the current modes of deep learning and machine learning, even the more advanced things, generative adversarial networks and such, become more creative with AI. I think there'll be a new paradigm. I don't know what it is, and many people don't know what it is who are in the computer science field, but just having more and more massive amounts of data to train a system and not fully understand how the system's operating is probably not the way in which we're going to get to the final evolution of artificial intelligence. But I think you're on the right target. If we share the data with certain companies and they collect massive amounts to train their systems and get more information to be able to understand better, to make their systems understand better and work more robustly, not fail in cases they haven't seen, which is common with artificial intelligence, that would happen. I think for companies that want to exploit artificial intelligence, that since, for instance, Google doesn't have access to their data, or it's the national government doesn't have access, say it's the energy industry, what you need to do is have a data strategy. So you want to understand how you collect the data for your organization, what's the important data, and then build your own models around that. Because there are lots of situations where there's not open data, which Google would never be able to access because it doesn't have that opportunity to do so. So I think it's about a data strategy in the current form of AI, and then in the future, I think there'll be new forms of algorithms being developed that will take us to another level of autonomy.
Thank you. Так, а теперь вопрос Волжского филиала.
Добрый день. Слышно?
Да, слышно.
Добрый день. Я представляю от лица студентов и преподавателей огромное приветствие нашему высокому сообществу из Комитета по присуждению премии Ассоциации «Глобальная энергия». Мы очень рады присутствовать на этой конференции и открытой конференции. Вопрос профессору Гриффитсу. Как вы считаете, насколько сумма капиталовложений в глобальную энергетику по реализации индустрии 4.0 позволит повысить эффективность производимой электрической энергии и сократит стоимость конечного продукта для последнего потребителя? Иными словами, какие капексы на единицу произведенной энергии будет наложено при реализации индустрии 4.0 для энергетических генераторов? Спасибо.
Спасибо за вопрос. So I think that's a good question. So with power generation in particular, there's a great opportunity to use 4IR tools to improve the costs of generation, improve the efficiency. I've mentioned previously one of the great opportunities in power generation is predictive maintenance. So every time that a power plant has a shutdown, it produces a challenge for the generation capacity for the grid. The less we have a shutdown, for instance, by being able to collect data, see what those data are in real time, and then be able to predict the onset of a failure, the better we'll be able to lower the cost of the entire electricity generation system, so we'll have to have less standby capacity. So these types of things, being able to sensorize power plants, see how they're operating, and before there is a challenge, or to take intervention beforehand is an opportunity that would be, say, an AI example. The other thing, as I mentioned, augmented virtual reality, workers in the plants themselves, if they are a cost on human labor, so if they're given the opportunity to understand in their environment more about the environment and take actions in an intelligent way, AI types of information that flow to them with whatever the apparatus maybe they're using for augmentation of their capability, that would be another way in which we can reduce costs of power generation.
Давайте последний вопрос Стивену с первой парты, пожалуйста.
Здравствуйте. Дубинин Михаил, ПАО ФСКС. Такой вопрос. Как бы цифровизация требует больших инвестиций, в частности в России. Это закреплено в тарифе. Вот. И существует ли в мире такая тенденция, что вкладывая в цифровизацию и развитие, и трансформацию, более мелкие энергетические системы или участники рынка могут изменить рынок, изменить экономическую ситуацию в стране и оказать большее воздействие за счет вооружения вот именно цифровизации? Все, спасибо.
The question in that, I didn't quite get the question.
Плохо слышно, да? Хорошо. Могут ли за счет цифровизации более мелкие сегменты рынка изменить экономическую ситуацию в стране?
No, that's a yeah. That's one of the nice things about digitalization. And so when you look at the size of companies, relatively speaking, the more you can allow the intelligence to operate for a small company, the more they compete against large companies in a better way. So the large company, for instance, the opportunity it has lots of people. They can hire lots of people. It has people doing manual work in a significant way. With a small company that takes the digital opportunity, they can have less people doing things with more augmentation or assistance with the work that they're doing. So I think the good thing about digitalization is it allows you to reduce your workforce to the extent as you can, hopefully without limiting jobs, as we said previously, would be a detriment. But start to get rid of those jobs which are just redundant, where you have lots of people doing manual labor, things that are kind of dull, recording transactions and doing things that a computer-based system is better able to do.
Спасибо большое. Коллеги, я думаю, что вопросов у вас очень много, вы можете их задать уже потом в кулуарах Стивену. И он с удовольствием, думаю, ответит на это. Спасибо большое. Так, ну и уже традиционно, какой лучший вопрос у нас, Стивен?
So I think the question about what's the impact of artificial intelligence on jobs is very good. It's one of the key questions we talk about today. In the green shirt.
Уважаемые коллеги, следующий наш доклад сделает Томас Близ. Тема доклада «Ядерные технологии, которые будут преобладать в энергетическом секторе в следующих десятилетиях». Пожалуйста, Томас.
Thank you very much. This is my third visit to your university here, and thank you for inviting me back. I'm the president of an organization called the Science Council for Global Initiatives, which was started after I published a book in 2008 called Prescription for the Planet, which is available in Russian, actually, if you contact Rosatom. I think ask one of your professors and they'll send you a bunch of free copies. One of our founding members is Evgeny Velikov. He was one of Gorbachev's top advisors. He's the guy Gorbachev called when Chernobyl blew up. He's the guy who started the ITER project, the International Fusion Research Project. And what we specialize in is in promoting the development of disruptive technologies, which are extremely difficult to deal with for people like RaeKwon, because what we look at predictions that are made, and we are promoting technologies that will make those predictions completely wrong. So, as an example, I was invited by the International Energy Agency to come to Paris when they were going to do a report on nuclear power, and we talked about advanced nuclear power systems. And the International Energy Agency is considered to be like the best prognosticator for future energy. And so they spin these scenarios where what'll happen if we have 10% nuclear, what'll happen if we have 50% renewables. And I tried to convince them to do one scenario where you had an economical, safe type of nuclear power that could compete with fossil fuels. They refused to do that. These organizations tend to be quite conservative, and especially organizations, energy organizations that have a large influence from fossil fuel interests. So it never happened. But this is what we work on. Now, there are a number of people. You might even call it a small industry that promote the idea that you can produce everything you need to run modern societies with renewable energy systems, excluding nuclear. And one of the most notorious ones is a person named Mark Jacobson. He's an engineer at Stanford University in the United States. This came out about 2010, I think. And it's a very desirable fantasy that this can be done. I'm going to make a couple assumptions here. One of the assumptions is that climate change is real and that it's a big problem, that we have to do something about it. And the other assumption I'm going to make, which you may or may not disagree with, is we can't run modern societies just on renewable energy alone. If you would like to explore those ideas in greater detail, I would welcome you to go to our website, and there's a lot of material about that. So that being said, how do we keep the planet lit? Mark Jacobson himself has a lot of prescriptions about, how many wind turbines and solar panels we have to build. And so we looked at if everyone on the planet was able to have as much energy as a citizen of Germany, which is about half of the energy that is used by a citizen of the United States, how much land would have to be covered with wind turbines and solar panels in order to make energy egalitarianism a reality? And you would have to cover an area the size of South America with windmills and solar panels. Now, aside from just the cost, you can hardly imagine the environmental impact of something like that. Now, if you wanted to produce that same amount of energy with, say, fast reactors of a design that General Electric has, you would have to cover an area about the size of the city of Buenos Aires. So if you're looking at environmental impact and cost, nuclear power is clearly going to be the winner here. I don't know what's going on, but okay, there we go. So at the moment, we've got fossil fuels producing the vast majority of energy, and clean energy is a small slice. And if we're serious about climate change, we have to make the blue part cover the whole circle. At the moment, if you look at the clean part, nuclear and hydro are basically it. Wind and solar substantially smaller. And the idea that you can crank up wind and solar to cover that circle is pretty crazy, but can we do it with hydro? The answer being no, because hydro is just not available all the time. I lived in California until very recently, and we have a lot of hydropower in California, but the problem is we had a drought that lasted for 3 years, and during that time, very little is produced by hydro. So about the only clean energy system that you have available that can be scaled up is nuclear power. So then the question is, how do you do it? This is a mock-up of the VVER 1200, which is the reactor that Rosatom likes to try to sell to everybody in the world. And it's a very good reactor. It's a great design. It's a light water reactor design, similar to the Westinghouse AP1000 that's being built in China and the United States. And what I've found is that countries that are building reactors, everybody's building light water reactors, and they develop a nice design, or what they consider a good design, and then they fall in love with that design. And we saw this in France with the EPR, which is absurdly expensive. It's just not working out. And we see it with in the United States with General Electric and Westinghouse, and we see it with Rosatom with the VVER 1200. So they fall in love with their design, and it's a nice design, and they've spent a lot of money putting it together, and a lot of engineers worked on it. And then they go out and they try to sell it, even though there are distinct disadvantages to light water reactors. Now, if you're talking about transforming the world's energy system so that we can deal with climate change, you have to have some kind of a design that's going to allow you to mass produce reactors quickly. And nobody has a light water reactor design that qualifies. They're generally very expensive, and they take a pretty long time to build, at least 3 years. So there are a couple other designs, and one of the tricks to mass production is if you can get away from high pressure systems, then you don't need pressure vessels, and you don't need the entire infrastructure that deals with high pressure systems. So the fast reactor that uses sodium as a coolant operates at atmospheric pressure. This one was developed in the United States in 1984 up to 1994. It's called the integral fast reactor. This is a simplified version of it, obviously, but the fact that it operates at atmospheric pressure is really important, and it's a great advantage. Now, that reactor operated at Idaho National Laboratory for about 30 years, worked great, and when they shut it down and they examined the materials, they found that there was absolutely no corrosion whatsoever. They could still see the marks that the welders had made on the metal 30 years before, after operating it at full at high temperature for 30 years. Now, Russia also built a fast reactor. The BN-350 was first built in what's now Kazakhstan, and that was a hybrid system that produced both electricity and desalination, and it worked quite well. They had some rather spectacular sodium-water interactions because their heat exchangers weren't great, but they just shut it down for a while and they'd fix it and start it up again. Then they built the BN-600, and that's run now. It's still running. It ran for over 30 years, and it was one of the easiest to run, most reliable reactors in the Russian fleet. A couple of years ago, they brought the BN-800 online, which is this one, and it also is expected to run every bit as well, and now they're building a BN-1200. But one of the issues with the BN reactors is they're making these great big giant reactors, and they're not really amenable to rapid mass production. So the question is, can we build reactors fast enough? There's about 400 gigawatts roughly of nuclear reactors in the world right now. And so if we really wanted to build enough of them, could we do it? So I talked to many of the engineers that developed the integral fast reactor system, and a commercial version of it called the PRISM, which was designed by General Electric. And I asked them, I said, if you had to compare building a PRISM reactor to building a heavy bomber in World War II, would it be easier? And they all said yes, easier, definitely easier than building the heavy bomber. Well, in 1945, as you all know, because I'm sure you're all great history students, the World War II ended in Europe in May and in Japan in August. And yet in 1945, the United States built 6,700 heavy bombers. Now, if you built 6,700 PRISM reactors, you could produce as much electricity as the entire world produced from all sources in 2009. So the problem of scaling it up is really not an issue. If you're serious about it, you can convert the world to nuclear energy to replace all the electricity from all sources in a very short period of time. So this is the PRISM design. This is about a 380 megawatt electric design, and it's amenable to mass production. But one of the reactor that I'm working with the most right now is called, it's a molten salt reactor, and I'm sure a lot of you in nuclear engineering are familiar with that. You have some people at the Kurchatov Institute that have been working with molten salt. But basically the way it works is you have a pot, the yellow pot, and in that pot is are basically slabs of high-density graphite, like you see in the picture on the right. And what happens is you take salt, you melt it, it melts at about 300 degrees centigrade. You dissolve uranium or plutonium or some thorium in that salt, and you run it up from the bottom through that graphite. And when the graphite encounters the neutrons, it slows them down, starts the fission process, so when the salt flows out of the top of the pot, it's about 700 degrees centigrade. Then it runs into a pump, which is the only moving part in this primary system, and that pump just keeps the salt flowing around at about garden hose pressure. So again, like the fast reactor, this is an atmospheric pressure system, and it's especially safe because the problematic elements in a nuclear accident are usually iodine, strontium, and cesium, but those elements are all chemically bound to the salt, so even in the event of an accident, they would not be ejected into the atmosphere. So, plus, because the salt solidifies when it gets down to 300 degrees centigrade, if in a worst-case scenario a terrorist came in with a big bomb and blew up one of these reactors, that liquid salt would go flying into the atmosphere, and as soon as it hit the air, it would turn into solid salt and would just fall. So you don't need evacuation zones around a reactor like this. Now, there was the problem with building these reactors is a light water reactor runs at about 350 degrees centigrade. These run at about 700. So that's a materials challenge that you have. What are you going to build it out of to make it last 60 or 80 years? Another challenge is that molten salt is a highly corrosive environment. And so people that wanted to build these, and there was one of these built at Oak Ridge National Laboratory in the United States back in the 60s. They ran it for 4 years and it worked great. So a lot of people went back, looked at this and said, wow, we should do this. But when I asked them, well, what are you going to make it out of? What materials are you going to make it out of that can handle that? And they never had a good answer. Finally, a couple of brothers started a company. They're shipbuilders, and they built the largest ship in the world, which is this giant supertanker. They designed this reactor, or this ship, and they built it in the most high-tech shipyards in the world, which are in South Korea. And they built it for $89 million in 10 months, which is ridiculously cheap and fast. And once they built it, they built 3 more. So the 4 biggest ships sailing around the world were built by these brothers. And once they did that, they thought, well, if we can build ships this way, this fast and this cheap, what if we could build nuclear reactors this fast and cheap? So they got some nuclear engineers together and they started a company called Thorcon. Now, a 1 gigawatt reactor system using the molten salt reactors would take up just that small amount of space on this big ship. So their idea was that they would dig silos along navigable waterways, along the ocean, along rivers, and they would bring in a ship with these modules on it, which are about 7 meters in diameter, and they would lift them into these silos, and they would build the turbine and everything, all the control mechanisms, the switch yards on shore. So when I got involved with them, I looked at this and I was thinking about building these in developing countries, thinking, you know, you're going to have problems with the construction quality, you're going to have problems with graft and corruption, you're going to have problems with work stoppages. And I said to him, you know, you know how to build the biggest ships in the world, why not build the entire power plant on a ship? Their immediate reaction was, oh no, that's not going to work. But after about 3 months, they go, hey, that's a really good idea. So they designed these ships. And these are fully integral power ships. And each one would be 500 megawatts electric. And you would just float them in. And you'd build them in a country that can afford to build them. Float them into virtually any country. and hook them up to the grid. Now this is especially attractive because we have billions of people on Earth that live in relative energy poverty. And if you want to raise their standard of living, the best way to do it is to get them energy, economical, clean energy. And yet many of these countries don't have the capital to build power plants. They wouldn't need it. So basically countries like Saudi Arabia, which has a $1 trillion post-oil fund to figure out what industries to invest in when people stop using oil so much, could build fleets of these power ships, and then they would essentially become utility companies. And say Ghana wants electricity, they float one of these down to Ghana, they plug it into the grid, and if they sold the electricity to Ghana at half the average price in Europe, they would be able to pay for a power ship in less than 3 years. So potentially countries that are heavily dependent on fossil fuels, like the Middle Eastern countries and Russia and Kazakhstan, other countries, Venezuela, could invest in shipyards to build power ships, and they could power the developing world very quickly and raise standards of living in a very speedy manner. So, and then, now the critical thing was that got me interested with Thorcon was, what are you going to build them out of? That question of what materials will you use? And having a lot of experience with big manufacturing, these guys figured out that you could build these reactor modules so cheaply and so quickly using this technology that you could just make them disposable. You would run them for 4 years and then you could throw them away. And it would still be cheaper than coal. So every 4 years you would have a can ship that would come in, and it would bring in a new reactor module and stick it on the ship there. So and then you would pump the salt over from the operating one into the new one, and then you let the one that has been operating for 4 years just sit there for 4 years, and the radioactivity that's in the material decays down to the point where it's, by the end of 4 years, it's low-level nuclear waste, which you can easily dispose of. So now you can build at least 10 of these reactors in a small shipyard. Saudi Arabia has built the world's largest high-tech shipyard. It's coming online this year. So you're going to be able to build, I don't know, 20 or 30 per year in this one shipyard. There's only 400 in the whole planet. So if countries like Saudi Arabia and Russia and China and Korea all get into this business, we'll be in a situation where we can literally transform the world's energy system to nuclear. So, and as far as nuclear waste is concerned, this is the waste from a power plant in the United States, from the entire operational life of the power plant. A lot of people that are anti-nuclear are worried about nuclear waste, but the Integral Fast Reactor project, the last step of it, it was, are we okay? All right. Part of the system was developing a recycling system for spent fuel so that you don't have a nuclear waste problem. And that project was terminated in 1994. I was able to find a very rich man, multi-billionaire, a few years ago, who really wanted to help out. And so he financed the project to finish up and design a commercial scale facility to recycle fuel from both light water reactors and fast reactors, and also from molten salt reactors. It's a one-step process. This has now been finished at Argonne National Laboratory, and it's ready to be built. So the thing is that if you're going to build non-fossil fuel electricity systems, and no matter how much wind and solar you have, sometimes they don't produce anything. The wind isn't blowing, the sun isn't shining, especially in the winter time you have the problem. So if you're going to have a backup system, you build nuclear for a backup. But you have to be able to produce peak demand. And so you build nuclear up to the point where you can produce peak demand when you need it. You wouldn't need it all the time. Wind and solar would be producing sometimes. But the thing about peak demand is that it's 2 to 3 times the average demand. And if you build nuclear to supply peak demand, nuclear is fine running at full power 24 hours a day. And the cost of fuel is trivial. Using fast reactors, it's actually free because you can burn spent fuel, you can burn depleted uranium. And so in a case like that, nuclear and solar become redundant. And you can run everything on nuclear. And that's politically very incorrect for me to say that. But it's true, so, you know, you can say what you want. If you have 2 to 3 times average demand, that means that you can produce all the electricity you need, and you're going to have 100% to 200% that much energy to use for other things. So what are you going to use it for? Well, one of the things, obviously, is for desalination. But you can also use it to make things that we now make out of oil. And this has happened recently with aircraft carriers in the United States and Russia, of course. You've got nuclear-powered aircraft carriers. Each carrier has several reactors on it. And the reason they don't have just one reactor is because they don't want to have to change to refuel them. They want to put a reactor on, and the reactor will last as long as a ship. So they put highly enriched uranium into these reactors, and then they run them at basically idle speed all the time. So they have a few reactors on these ships. And somebody said, well, you know, we have to have jet fuel for all the jets. So we have tankers that come up and they load jet fuel into tanks. But why are we doing that? We've got all this excess energy. Why don't we just make our jet fuel out of air and water? Because you got carbon and oxygen and hydrogen, right? That's all you need. And so now some of our aircraft carriers are making their jet fuel just with excess energy that they get from their nuclear reactors. And we can do the same thing on a much larger scale when we convert to electric, to nuclear around the world. So what happens to the countries that rely on gas and oil? It is going to be a big disruption, okay? There are millions of people that are employed in these industries. There are countries that you know, whose economies rely on that, including Russia. This is going to be a really big question. But it's going to have to be something that you deal with, because climate change politics is very real. And I personally believe that climate change itself is an existential threat. But I have the benefit of hanging out with some climatologists that really know what they're doing. So whether you believe it or not, the fact is that it's influencing policy around the world, and we're going to have to deal with that. The thing about creating jobs, now Russia is more aggressive than any country in exporting nuclear power. And I suspect that once these new reactors are demonstrated, which is going to happen in as little as 4 years, Russia will quickly start building them. And I've been talking to Rosatom about this for the last 3 or 4 years. And, you know, it's easy. Russia has a lot of engineering capability, and you guys are going to be doing it. So the thing is, if you produce lots and lots of economical energy, you're going to be uplifting the standards of living of billions of people on Earth. That's going to create lots of jobs, okay? I can't say how many jobs in which sectors, but ultimately it's going to be a global transformation, but hopefully a positive one. Again, I would invite you to go to our website. There's a lot of material that you can read there about the renewable versus nuclear debate and other cutting-edge technology ideas. Thank you.
Здравствуйте, Исаев Расул, Московская объединенная энергетическая компания. Спасибо большое за ваш доклад. У меня возник следующий вопрос, два небольших вопроса. Первый, можно ли в связи с развитием автоматизации, роботизации полностью доверить управление ядерными источниками энергии роботам, так скажем? И второй вопрос, как решить проблему утилизации ядерных отходов? Спасибо.
Thank you for that. As far as the nuclear waste issue, as far as the nuclear waste issue is concerned, I believe I touched on that with the recycling system that I showed you there in one of those slides. It's a one-size-fits-all solution, and it's ready to be built on a commercial scale. They've already recycled about 30,000 fuel pins at laboratory scale, so that's just a solution that's waiting for building. Your other question was, robotics. The Thorcon power ships are basically so simple that you wouldn't need any operators. You could operate them all from a central facility. No matter how many, you could have one central global facility to operate all of them. They're very simple to run. You can see it's just a three-part system. It's just fluid running around through a heat exchanger into a pot and through the pump. So yeah, it's not going to create a lot of jobs. One of the things that when people are talking about wind and solar, one of the things they rely on as a sales point is look at all the jobs it creates. This is going to create very few jobs. Because one reason is because it's extremely efficient. So, I mean, you can create lots of jobs in a system that's extremely inefficient, but is that what you really want? If you create lots and lots of cheap energy, there will be lots and lots of jobs because plenty of people around the world are going to be raising their standard of living. So I'm not going to worry about it.
Добрый день, ПАО «Татнефть», Миронов Дмитрий. Вопрос следующий. Насколько этот проект, он готов как коммерческий продукт, и можно ли его использовать в сложных климатических условиях, например, при освоении арктических шлейфов?
Okay, a lot of you are engineers, some of you are IT people, I assume. So the next time you do something like this, you're going to make it so that you can have two microphones, right? Yes, the Thorcon power ships are actually ready to be built. It's a 4-year project. They're trying to put the money together right now to pull the trigger on the 4-year project. I've talked with some of the best nuclear engineers and physicists in the United States who actually built reactors, designed and built reactors, and some of them also are still working at Argonne National Laboratory, and they all agree that this could easily be done in 4 years, maybe less. The problem in the United States is the Nuclear Regulatory Commission is hopelessly upside down. So several of the people that want to build truly advanced reactors are going to other countries, and Thorcon is going to other countries. Matter of fact, today, maybe even right now, a delegation from Russia is in discussions about selling the startup fuel for the first reactor to the Thorcon people. So we expect that before the end of this year, we'll start the 4-year project, and at the end of that, we would have a full 500 megawatt power ship ready for testing, and within a year you would be able to start mass producing them. So, it sounds crazy, but literally in 15 to 20 years we could see a wholesale conversion to nuclear power around the world. And then RaeKwon would have to do some new projections, but I'm sure he'd be happy to do that.
Коллеги, у нас времени действительно немного. Я хотел бы еще слово предоставить нашим филиалам. Есть ли у них вопросы? Смоленск, Волжский. Нет вопросов, да, я так понял?
У нас появилось много вопросов. Мы приглашаем всех приехать в Волжск в следующем году, может быть.
То есть точно такую же конференцию провести у вас?
Да, да. Будем.
Ну, если наши спикеры согласятся, то это возможно.
Приглашаем.
Спасибо. Ну и последний вопрос из этой аудитории, пожалуйста.
Добрый день. Мельников Михаил из компании «Росгидро». Очень приятно было послушать ваш доклад. Я, как в сфере прошлой работы, объездил практически все атомные станции на территории Российской Федерации, поработал на них. Вот, и уверен в том, что атомная энергетика, так же, как и вы уверены, что она безопасна для населения. Вот. И вопрос был связан с тем, что хотелось бы услышать ваше мнение, потому что Европа массово отказывается после аварии на Фукусиме от ядерной энергетики. Как вы относитесь? Вот ваше мнение к этому вопросу. Все, спасибо.
Thanks for that. What a lot of people don't realize in terms of nuclear safety is that the other two reactors at Chernobyl kept operating until the 1990s, and that nobody died in Fukushima from radiation. The deaths were due to trauma from people moving out when they didn't really have to move out. I think the only radiation damage to people actually happened on some U.S. ships, because after the tsunami, they sent some aircraft carriers, some other ships, into the area to help out with the tsunami damage, and they were right in the path of the radiation. So that's being hashed out in the courts in the United States. But some countries just totally went off the deep end, Germany included, and said, no, we're not going to use nuclear power. And they have perfectly functioning nuclear plants in Germany, and they're closing them down. It was interesting, RaeKwon's slide of Sweden, where he talked about how they're taxing their energy, and yet their carbon emissions are going down. But they have really much higher energy prices in Germany and Denmark, and their carbon emissions are going up. So is it the taxes? It's not really the taxes. The fact is that Sweden gets all of its electricity from hydro and nuclear, like France does. And they're the only two countries that do that. And that's why Sweden's emissions are going down. It's not a function of the carbon tax, really, or the tax on energy. So, you know, I deal with this all the time. I deal a lot with people who are afraid of nuclear power. There's a movie called Pandora's Promise. You can find it on YouTube. I screened it here, I think, last time I was here a few years ago. And it explains people's fears, and it explains the realities. And so, you know, I, as part of what I do, I try to educate people about the realities of nuclear as you know them. And it's a constant job, because there are a number of people who make a living scaring people about nuclear power. Matter of fact, I was over at Fukushima in Building 4 when they were transferring the fuel from the spent fuel pool. And when I came home, I was in the building while they were doing it. And when I came home, I went to one of these Fukushima freakout websites, and there was a picture of a big fire. And they said that Building 4 had had an accident while they were transferring the fuel, and it was spewing radiation into the atmosphere, and it was like an existential crisis. And it was crazy, because I was over there, and it was fine. Everything was good. So there are a lot of people that just lie. You know, that's their business. And it's something that we have to deal with. Thank you very much. I really appreciate the opportunity.
Завершая эту сессию, хотелось бы узнать у Томаса, какой был лучший вопрос. Очень приятно. Глобальная энергия, приз. Так, коллеги, большое спасибо всем спикерам. Это было очень интересно, и я так понимаю, что даже разный взгляд на те проблемы, которые существуют в энергетике, они, в общем-то, не разъединили, а объединили эту аудиторию. И это было видно по вопросам. Что я хотел сказать? У нас остался последний пункт программы. Каков он? Поскольку что нас интересует дальнейшее взаимодействие, мы решили подписать протокол о дальнейшем сотрудничестве между Халифским университетом и Московским энергетическим институтом. И мы сегодня это соглашение, вернее протокол о намерениях подпишем.
Ассоциация глобальной энергии.
Так, на этом наше мероприятие закончено. Большое всем спасибо. И я думаю, что мы такие встречи сделаем традиционные. Спасибо, всего доброго всем.
Спасибо, коллеги.